Hello guys. In this lesson we are going to write a short PLC program to a water tank filling using a level sensor and a control valve, which are analog input and output respectively. The process involves fine-tuning the flow of water to the tank through an electrical control valve with rate opening is function of the water level detected in the tank by the level sensor. Let us for instance use a proportional regulator. This implies the control valve opens up proportionally to the error between a water level setpoint, which is the desired level, and the current measured water level in the tank. We suppose the level sensor delivers a 0-10 volts range and corresponds to min and max water level, and the control valve is adjusted by the same signal range, which corresponds to closed or fully open. We switch to project view, then we add a 1500 CPU. We pick a compact one with integrated analog input and outputs modules. As it is shown here, the CPU has a 5 channels integrated analog module and 2 channels output one. As a first step of analog programming, we need to set the parameters of the analog devices. As we know, both the level sensor and the control valve both deliver 0 to 10 range voltage signal. Well, we set the modules to this, then we check the starting addresses of each. We are done with the parameter settings. We can now start programming. As usual, we open the main OB. As a rule of thumb, when analog devices are involved in programming, the first thing to do is scaling. We start by the level sensor, which is the input. As we deal with the 1500 CPUs, we need two instructions: the norm and scale. We drag them from the conversion folder operation, then we enter the level sensor parameters. For those who are not yet familiar with the analog programming, they can check the previous video on Introduction to Analog Programming. We rename the tags to show clearly how scaling is performed. For a tidy program, we can rename the networks to show the role of each within the PLC program. In the second network, we make the control valve scaling, which is the output. In the third network, we make the program that controls the water level in the tank. Actually, we are going to see how to put a proportional action in PLC code. For this we need some basic math functions. While we open the math function folder, we pick the subtraction instruction. This will calculate the error between a setpoint water level and the current measured water level. The instruction will therefore have first input a setpoint of 80 for example, the second input is the scaled water level which stands for the process input. The result will be kept in double word space memory which is then multiplied by the gain. Thus, all we need is a multiplication instruction from the same folder. It's noteworthy to mention that this program does not stand for a solution to the process since in such processes, we often use PID regulator. However, today's lesson focuses on the practical use of analog inputs and outputs. Moreover, it's also shown how to use math functions in a practical way rather than dedicating a whole lesson which would seem tedious. Beware again, here the choice of the process gain depends on the desired process response. In our example we start with 1, then you can test other values by yourself to see the difference. Now it remains to move the result of these operations to the output. To the purpose, we use the widely used instruction move. The instruction will have as input the value we need to copy, and the output will hold the content of the input. The code seemed to be complete. Well, since we have already opened PLC Sim, so all we need to do is compiling and loading the program. We load our variables to PLC Sim, then we pass to simulation. Beware, if there is an issue in the connection between the two software, the tags will not appear properly. We click on the input. Hopefully, you will notice the math relation between the input and output which is proportional. As we can see here, the output decreases when the input rises and vice versa. At a practical level, this means the control valve closes at water high levels and opens up when low levels are measured, thus regulating the water flow to the tank. This is the mathematical foundation of the proportional action. We can test some values to see the process response, then we go back to the program and change the set point to 100 and make a comparison. We test the 27,648 value, which corresponds to the water tank max. This resulted in the output fully closed. Now we enter 13,648, by reason we will see the control valve 50% closed. Finally, we can speed up or slow down the output response by tuning the gain value. Above all, it's the proportional relation which matters in this example. Plus, we should remind our dear students that in this kind of processes, it's the PID action which is used. We will deal with this further in the course. Hope you enjoyed the lesson. See you in another video, and make sure to give us a like to support us for more videos.